Hi there everyone, welcome back to my channel. I'm the GCSE science teacher. In today's video, we're going to be learning about some GCSE chemistry topics, specifically focusing on water waste treatment and potable water. So I hope you do find this video helpful. If you do, feel free to let me know by giving the video a thumbs up. Share this with someone else to help them with their revision. And if you'd like to join this lovely community, feel free to click subscribe and the bell so you get notified of new uploads from me. Thank you so much for all of your support. Let's get started. So the first thing we need to know is this definition of the word potable water. This is water that is safe to drink, and essentially water has come from a variety of areas that we drink. So it can come from the sea if we are to treat it correctly. We can use a few methods to remove that sodium chloride or that salt, because in its raw state we can't drink seawater because it can make us feel really sick and dehydrated because of the salt content. We can also get water from places like our rivers and our lakes, and this is essentially where all the water is collected after rainfall. However, we can't again just drink that water straight away because it's not yet potable. And the reason for that is because it can contain some impurities and some pathogens as well. So different microorganisms such as bacteria, viruses, fungi, protists, all of these types of microorganisms that can cause disease, we have to destroy and remove before we can call it potable water. So how is this done? Well, we can use a range of sterilizing agents such as chlorine, ozone, and UV. And you don't really need to know their mechanisms and how they work. You just need to know those key examples. Another way we can also make sure the water is potable from these places such as the rivers and lakes is to pass the water through some filters, and this will essentially remove any of the insoluble solids that could be in the water as well. So let's say, for example, we have seawater and we want to separate that salt from the water so we can get potable water. Now, this is a process called desalination, and there's two methods we can use. The first is distillation and the other is reverse osmosis. So let's talk about distillation first of all. Now, this is a process which essentially is used as a separation technique. So we are simply removing that salt from the water by heating up the seawater until it begins to boil. So the internal energy starts to increase, those particles start to gain that energy and move around more. However, we need to keep heating up that substance until evaporation occurs. That is a state change where the liquid becomes a gas. So this liquid water changes state into a gas and forms this vapor. Now, the vapor then is collected in the condensing chamber and it starts to cool down. And that's very important because as a gas cools down, it starts to condense back down into a liquid. That liquid is run off and collected, and you can see this experiment set up here, the conical flask. Obviously, if this was water that was being provided to an entire area of people or an entire population, this would be more of an industrial-sized process. But this, of course, is just showing simple distillation experiment apparatus here. But as you can see with the conical flask, that water that's collected is pure water. It only contains hydrogen and oxygen, and of course, therefore, it is potable as well because it is safe to drink now. Pure water, by the way, is not the same as potable. It just happens that this is pure water. Pure water just contains hydrogen and oxygen atoms, but potable water is water that is safe to drink, simply put as that. Now, the one downside to this type of method is that the liquid that's left in the round bottom flask that we're trying to evaporate off, we can actually evaporate all the water and leave just the salt behind. Or more probably, the case is that the water left behind is a very highly concentrated solution. And this therefore contains a lot of that salt, but very minimal amounts of water. So we have to be very careful where we place that water waste from this method, because actually, if we were to place it back into the sea, it can definitely change the concentration of salts in the seawater and therefore affect the biodiversity in the sea as well, meaning that lots of animals, aquatic life can start to die and diminish. So we've got to be very mindful of this. Another thing to consider as well, this process requires a huge amount of energy because, of course, we're heating up a huge volume of water and this can take a long time. So therefore, a lot of energy is needed. It's very pricey. But of course, lots of countries around the world will use desalination as their main source of gaining potable water because seawater is their main source of water as well. So they may also have their own energy systems and things like that, fossil fuels, etc., to do this, so it doesn't cost them as much. However, if we think about the global impact of burning fossil fuels for this process, of course, that has quite a negative impact, as we've discussed here on my channel before. So there's quite a few limitations, but of course, the main positive is that you're going to obtain potable water from it. Another method that we can also use for desalination, like I said, is reverse osmosis. And this is a process where water is put under very, very high pressure and essentially passed through a membrane that has tiny little holes in that essentially only stops the ions or the salts in the water from passing through. So it essentially pushes that water through and separates those ions, those salts from the water. Now, again, this is very expensive, this process to do, because the equipment is very expensive and there is a lot of water waste that is also produced as a result. So again, some limitations, but also some advantages that both do produce that potable water. So the next little bit that you need to know is this idea of how sewage is treated. All the wastewater that we as humans accumulate, either through domestic uses in our homes, whether it's in the industrial processes, in factories, or even agriculture. Remember, water is used in such a variety of ways, and the waste products as well are also accumulating in our society. So we need to do something with it. Now, I mentioned agriculture, industry, and also domestic use. And it's important that we know the differences and the hazards associated. So, of course, with domestic use, we as a society have toilets and showers and sinks that have a lot of water that is run off into the sewage system. And that's where we will discuss this topic. But also with agriculture, if we are spraying our crops with fertilizers, which essentially encourage the growth of crops and plants, we then give the plants the water that they need for growth as well. Essentially, that fertilizer can actually run off into our rivers and lakes and cause a phenomenon called eutrophication. And this essentially is a process where the fertilizers encourage the algae in the lakes to grow, and this is called algal bloom. Now, that sounds great, but the problem with that is it actually covers the entire lake with this algae and stops the light getting into the lower level plants underneath the water in the lake. And that means that there's less photosynthesis that can occur with those plants, and therefore less oxygen that is entering the lake in the first place to help support the life that is in there. So a lot of aquatic life will die as a result of this. So it's very dangerous and something that we need to consider, especially for biodiversity reasons. Another thing as well, like I said, with industry, if we're using a lot of heavy metals or metal compounds or chemicals, this can also leak out into the environment if we are not being careful with how we remove this waste or what we do to treat it. And this can lead to things, again, like another phenomenon called bioaccumulation. And essentially, this is when metal compounds or chemicals can actually start to increase in prevalence in our food chain. So smaller species may consume some of the food in a food chain, and they will then consume those toxins as well. And this starts to then build up in the food chain and start to be really in high volumes or levels in those higher species, including ourselves. Remember, we are part of nature. We are part of that food chain as well. So it's very important that we kind of consider all the different impacts of what we do as a society and how it affects ourselves, but also the world around us too. So like I said, there's quite a lot to consider here, and we need to be aware of how we treat our water waste, specifically sewage. Now, in the news in the UK recently, I don't know if you guys are in the UK, let me know in the comments section below, but there was a big news article that came out recently, I'll link it in the description box for you, where sewage was being dumped into our seas. And people, rightly so, were very frustrated by this, very disgusted by this, because lots of people go to the seaside and you don't expect there to be sewage there, right? But it's a very dangerous thing as well, because raw sewage that has not been treated contains bacteria that can be pathogenic. This is why cholera was so high in prevalence during the Middle Ages, because people would literally go to the toilet and throw it out their window. And this will contaminate water supply. But also, not only the pathogenic element, but nitrogen compounds are very high in human waste, and this can cause a lot of environmental problems as well. So, yeah, that's a whole issue in itself. But how is sewage treated usually? What do we need to know for the exam? So we essentially need to use something called a screening and grit removal stage, where the sewage will enter a big factory, if you will, and it will go through a screening stage where all of the solid waste is actually screened off to separate the liquid from the big solids that are in there, as you can imagine. And then after this, we have another part of the method, which essentially there's this sedimentation stage. So any of the liquid left behind, we let the solids that are too small and have passed through that screening of initial stage, they start to settle to the bottom of the tank. And this bottom of the tank contains the solids called sewage sludge, which sounds really gross, doesn't it? But this sewage sludge and the liquid at the top, called the effluent, are separated in this stage. And then the final stage is to use bacteria to digest these two different parts. So the bottom stage, the sewage sludge, is digested anaerobically by bacteria without oxygen. And the effluent is digested aerobically with oxygen. And this will treat our sewage to make it less harmful to the environment. And on that wonderful note about sewage, I hope you enjoyed this video and you found it helpful for your revision. I've been the GCSE science teacher and you have been curious. If you did enjoy this video and you'd like more videos like this to help you with your GCSEs, please let me know in the comment section any video requests. You can also give this video a thumbs up to let me know you enjoyed it. Also, feel free to subscribe and join this wonderful community here on YouTube. I also have an Instagram and TikTok. Everything is at the GCSE science teacher. And yeah, if you want more videos from me, I'll link them for you here. In the meantime, have a great day and I will catch you in the next one. Take care.